Hi guys, let's do average of levels in binary tree. So we're given the root of a binary tree and they want us to return the average value of the nodes on each level in the form of an array. And they say answers within 10 to the negative 5 of the actual answer will be accepted. So in example 1, we're given this tree and we would output 3.000, so on, 14.5 and 11 in this list, and that is because the average values of each node on level 0. So this is level 0, so since 3 is the only node here, then the average is 3. On level 1, which is this level, the average is 14.5, and on level 2, which has these two nodes, the average is 11. So we return a list storing these averages, so 3, 14.5, and 11. In example 2, we're given this tree and we would output this list because the average of the first level, or level 0, is 3. The average of level 1 is 14.5 and the average of level 2 is 11. So, okay, those are our only two examples. So basically for this problem, we want to iterate through the tree, visiting each of the nodes and level by level, which is going to indicate a BFS. And for each level, we just want to calculate the average and store that average in a list. So that's basically it, pretty straightforward. So let's start by creating our list that we're going to be storing the averages in and our queue to start our BFS. So we're going to say list of doubles because we're returning a list of doubles here. I'll just call it averages is new array list. And then we'll do the same thing for our queue. So we're going to store a queue of tree nodes. And then we're going to add the root into the queue. So queue.add root. So now we have an empty list of averages. I guess they usually use square brackets for a list. And a queue which only has, so if we go by example 1, then it just has 3 currently. Okay, and then while our queue is not empty, then we're going to be doing our BFS. So nodes in current level is the size of the queue, and then this is just typical BFS stuff currently. Okay, and then let's just finish off the regular BFS stuff. So oops. Okay, so this is just regular BFS stuff currently. We also are going to return averages at the end, which is our list of averages. And then now, so we need to find a way to calculate these averages and add them into our list to return. So since we're calculating the averages for every single level, this is going to reset on every level. So this for loop is looping through every node in whatever level we're in, right? So this outer loop is for each level, and this is for every node in each level. So since we wanted to reset at each level, we're going to want to initialize it out here. So we'll actually make it a double. So average, and we'll set that equal to 0 to start, because basically what I'm going to do is I'm going to add the value of each node in the level to this average, and then divide by nodes in current level, just because we already have the size here, which is perfect, and then add that average into averages, and then it's going to reset for every level here back to 0. So down here, if we remove the node from the current level, then that's empty. This is a 3. And then we want to, since the average of, well, we're going to want to add this 3 into our average. So average plus equals node.value. So now average is 3. And then we will, after we add these other nodes into the queue, we can divide equal by nodes in current level, which in this case is just 1, because we only have 1 node in this level. So it's still going to be 3, and then we're going to add that into averages. So that should be it. Let's do another loop so we can see what's going on. So node.left from 3 is 9, so we'll add that into the queue. Oh, and then since we added average into our averages, this will be a 3.0. Okay, and then node.right for node 3 is a 20. So average gets reset to 0. So node in current level is 2 because we have 2 nodes in this queue currently. Then our top node is going to be 9, which we remove from the queue. And then average plus equals 9. So now average is 9 because it was reset to 0 up here. And then we'll add node.left and node.right to the queue, which is null for 9, so we don't do anything. And then, oh, okay, my bad. So actually we want to take this out. I put that in the for loop, but it should be outside of the for loop here, but in the while loop. Because we don't want to do this for every single node we add. We want to do it at the end of every level. So I had that in the wrong spot. Sorry about that. I'm glad I caught that. Okay, so the next iteration of the for loop, so we haven't gotten here yet, okay? We will add, okay, so this node will be removed and that is stored into node. Average will plus equal 20, so this is now 29. Then we'll add node.left and node.right, which is 15 and 7. So these get added. Okay, and then now that we're at the end of the for loop, then we will calculate the average. So 29 divided by nodes in current level, which is 2, is 14.5. So we'll add 14.5 into the queue, or sorry, into the averages. And then, okay, next level, we now have 2 nodes in this level, so that's still 2. Average gets reset to 0. Then node is going to be 15, and 15 gets removed. Average, which was reset to 0, now plus equals node.val, so that becomes 15. Then node.left and node.right are both null, so we skip that. And then next iteration, then 7 gets removed from the queue and stored into node. This becomes 22 because we add 7 to 15. Then node.left and right are both null, so we skip that. And then average divide equal by 2 since we had 2 nodes in this level. So this average will become 11. And then we'll add 11 into averages. So this will add 11.0. And then we exit this loop and then we return averages. So if we check averages is now this, which matches up with this. So we should be good. So let's submit. All right, so our time complexity. So if we think about what we're doing here, right, we're just doing a BFS where we visit every single node exactly once. And so that is just going to be O of n, where n is the number of nodes in the tree. Then our space complexity, if we think about our data structures here, we have this double of averages and we have a queue of tree nodes, and that is it. So the queue is the same for any BFS, pretty straightforward, right? It just stores every single node, worst case, because, well, not every single node, but like worst case is going to be O of n because worst case, it's going to, if we have a complete tree, it's going to store every single node that's in the bottom layer of the tree, which is O of n over 2, and then that simplifies to O of n. So that's O of n, or we could say O of w for O of width, either way. Yeah, and then averages. So if we think about what we're storing in averages here, this is just going to store one node for every level, or not node, one value for every level, because it's the averages. So if we have 3 levels like we do here, then this will store 3 values. So that is going to be proportional to the height of the tree, but that is always going to be less than O of n anyway. So O of n will just take over that one. So this will be O of n, where n is number of nodes in the tree. And that is it for this problem. Thank you guys for watching, and like and subscribe if you found this helpful. Bye!